In the last activity, we looked how to find the vertex by finding the zeros or the x-intercepts and then looking at the middle or exactly halfway in between those. Now we're going to learn a method that goes directly to the vertex. So if I look at a quadratic equation, y equals x squared plus 6x minus 7, I know that it's a parabola or a U shape because it has the x squared. Because it's positive 1 in front, I know it opens up. So I'm looking for that lowest point, the vertex, which is a min in this case. This is called an incomplete square because for vertex form of a parabola, we want to have a full bracket squared. Here we just have an x squared, so it's not complete yet and we need to do that. So sometimes when I teach this in class, I call it the funky zero because we are going to create a funky zero and add it in. I'm not allowed to change the value of this, but by adding 0, I keep it the same. It will look different, but it'll have the same value or weight. But I have to be careful on how I pick the 0 because I want certain things to happen. So it's kind of like a dance. The first step of the dance is always half of a number. It's always half of the coefficient or the number in front of x, which is in this case is a positive 6. So half of 6 is 3. Second dance step is square that number. 3 squared is 9. Now my funky 0 is always this number subtract itself, the positive 1 then the negative 1. So my 0 is 9 minus 9. So when I say do the funky 0, I literally mean take half of the coefficient, square it, make your 0. Now the 0 always goes in between the x term and the constant. Negative 7 is our constant because it doesn't have a variable with it, so I slide it over. In between, I'm going to put the positive 9 first, then the negative 9. It's always the positive 1 first. If I look at the first 3, that's a regular trinomial. So I'm looking for two numbers that multiply to give me 9 and add to give me 6, which is 3. It's 3 and 3. So I could write two brackets, both with x plus 3 in them, but mathematicians are lazy. Why write something twice as a multiplication when we can just say that's x plus 3 squared, or x plus 3 bracket multiplied twice. Now the negative 9 I haven't used. It's not part of this trinomial, but it has to be included in the question to balance out. But now what I'm going to do is put those two together. Negative 9 subtract 7 is negative 17. This is called vertex form of a parabola because I can literally pick the vertex out. It's the opposite of what's in the bracket with x. So in this case, it's negative 3. And then the number at the end, negative 16. So the opposite of positive 3 is negative 3. And then I take negative 16. So that's the vertex. I know this parabola opens up because it's a positive 1 in front, and because it's a positive 1, it's a normal parabolic or quadratic pattern. You might have learned this a couple ways in grade 10. The way I teach my students is quad for quadratic literally means a square. So the square pattern is 1, 2, 3, 1, 4, 9. I square each of those numbers. So that's the normal pattern. Because there's no number in front other than a positive 1, I don't adjust that. And I'm going to show you how to apply this, and I'll show you how to adjust it. So the vertex is negative 3, negative 16, and we're going to do a normal pattern. So I go to my graph. I'm going to count by 1s on the x's. So that'll be negative 4. And that'll be positive 4. So my x's have to be the same all the way across. I can't count by 1s on my y's because I won't get to negative 16. You might have a graph that's big enough. So I'm going to count by 4s. So the y's do not have to be the same as the x's, but the y's have to be consistent top and bottom. So my vertex, which we discovered, which was negative 3, negative 16, is going to be there. Back 3, down 16. Now, if you memorize this pattern, I'm going to, from the vertex, go over 1, up 1. From the vertex, go over 2, up 4, and then I'll talk about the 3, 9. So over 1 is a full space. Up 1 is only a quarter of a space because up or vertical, I've made every space 4. So that's over 1, up 1. I go back to the vertex and I go over 2, up 4. Over 2, up 4. That's what those numbers mean. From the vertex, go over 1, go up this number. From the vertex, go over 2, go up that number. And because of the symmetry, we do the same thing in both directions. Now, I always say 5 points makes a parabola. The vertex and 2 points on either side. If you want to graph the 3, 9, you absolutely can. So 1, 2, 3, up 9, 4, 5, 9. It's going to be about there. 1, 2, 3, about there. But as long as you have 5 points, I'm happy with that. The vertex and just 1 point on either side isn't always enough. Sometimes you have to make do with it though. So I graph my parabola and now I'm going to label it. You could label it with our equation. There's nothing wrong with that. It is better though to label it with the equation that it was given to us as x squared plus 6x minus 7. But in my classes I mark both of them right because at least you've labeled it with an equation. Looking at B, there's a slight problem because I have something in front of my x squared. This something is a negative, so I know it's going to open down, and my vertex will be a maximum in this case. But you are not allowed to complete the square with anything in front of the x squared. So I'm really going to take out a negative or a negative 1. Negative x squared divided by negative 1 is positive x squared. Negative 10x divided by negative 1 is positive 10x. The number at the end always just hangs out until we're done. So I've left lots of room for my 0 and just moved the negative 20 to the end. And because the negative 20 isn't in the bracket and it never will be, I don't worry about taking out that negative. I only common factor the negative from the first two terms. Now I'm going to do the funky 0. First step is half of. In this case, it's half of positive 10, which is 5. Second step is square. 5 squared is 25. So now my funky 0 is 25 minus 25. The negative 1 keeps hanging out in front. These first three things factor to x plus 5 twice. Two numbers that multiply to give me 25 and add to give me 10 are 5 and 5. Instead of writing the bracket out twice, I just put a square on it. You might have noticed the first step in the last question was 3, and that was the answer in our bracket. This question, the first step was 5. That's the answer in our bracket. That's always the case. So you can cheat and pull that number, and it will always give you the number inside your bracket. Now I have to be careful with this negative 25. It's a necessary part of the question to balance out the positive 25 that I needed to make this square bracket work. But now it's coming out of the bracket. Everything inside the bracket is waiting to be multiplied by negative 1. This stuff down here is still in the bracket, so it's still waiting. This is going to come out of the bracket, so I have to multiply it by the negative 1 because it's no longer in the bracket. Negative 1 times negative 25 is positive 25. Again, I put the two numbers at the end together to give me positive 5. So now my vertex is opposite of what's in the bracket, number at the end. So negative 5, positive 5. I know this parabola opens down because of the negative in front. And because it's negative 1, the square pattern stays the same. I just have to remember to keep that pattern going down. So now on this graph, I am going to be able to count by ones. So that's going to be 4. That's my y. Everything will fit if I just count by ones. And don't feel like you have to label every tick. As long as you label enough to give an idea of scale, that's fine. So my vertex was negative 5, 5, which is there. And again, I have a normal square pattern, 1, 1, 2, 4, 3, 9. And I just have to remember to do that pattern going down because of the negative in front. So over 1, down 1 in both directions. Over 2, down 4 in both directions. So 2, 4. You kind of get used to the symmetry and can start filling in points. You could do the 3, 9, at least on the right-hand side, but again, 5 points makes a parabola. Join them up as best you can, and then label with, I'm going to label it with the original equation, but you could label it with the x plus 5 squared plus 5, whatever one you prefer. The top one is better in the sense that that's what we are asked to graph. Okay, looking at another example with a number in front. This time we have the 3. And again, if there's no number in front, I just start doing my pattern. But in this case, I have to take the 3 out of my x squared because I can't start my dance step until there's a positive 1 in front of the x squared. 3 comes out of negative 12 and gives me negative 4. Negative 12 divided by 3 is negative 4. I'm going to leave room for my 0. The 5 I'm not going to touch. I'm just going to keep it at the end of the question because that's where it's going to end up anyways. So now in this case I'm doing half of negative 4, which gives me negative 2. It's important to carry the sign because that'll help us create our brackets. Negative 2 squared is negative 2 times negative 2, so it's positive 4. So my funky 0 in this case is plus 4 minus 4. The 3 stays. The first 3 things collapse to x squared, and I just have to figure out what goes in there. You can ask yourself 2 numbers that multiply to give me positive 4 and add to give me negative 4, or you can cheat and just go and grab that number up there. The negative 4 at the end comes out of the bracket, and it becomes a negative 12 in the process because it's no longer inside waiting to be multiplied by the 3 like this is, so we have to do the multiplication by 3. So then I end up with negative 7 at the end. So my vertex is positive 2, negative 7, opposite same. It opens up because it's a positive 3, and now because it's a 3, it's going to be a triple pattern. How I deal with that is I always start with my quad or quadratic pattern. 1, 1, 2, 4, 3, 9. You never, ever, ever touch the first numbers. It's always the up or down numbers that we touch, and I'm literally just going to triple them. If it was 1/2, I'd cut them in half. If it's 4, then I multiply them by 4. Now, there's probably no way I'm ever going to fit a 327 on my graph because that's a lot of spaces, but again, I'm not going to worry about it. I have my 1, 3 and 2, 12 because I multiplied the pattern by 3. So I'm going to count by 1s on my x's. I won't quite have enough room if I go by 1s on my y, so I think I'm going to go by 2s. So 2, 4, 6, 8, negative 4, negative 8, that's my x-axis. So my vertex was 2, negative 7. So 2, negative 7 is going to be there because 1 is half a space in this case. And so my pattern became 1, 2, 3, 1, 4, 9, but because I tripled it, it's 3, 12, 27. So I'm going to go over 1, which is a full space, up 3, and now I'm careful with my scale because that'll be 1, 2, 3. Over 1, up 3. Then I'm going to go over 2, up 12. So over 2, up 12. And now you can either count it out, but if I'm at negative 7 and I go up 12, I should be at positive 5. Over 2, up to positive 5. I'm not even going to try to fit the 27 on. It's not going to fit on my graph. But now I'm going to come through, connect my points, and label my graph with either equation. I'm going to label it with the first one. You could label it with the one after we completed the square. So the final question, find the inverse. Remember, inverse means switch x and y. Graph the original and the inverse on the same axis and give the domain and range for the original in the inverse. Well, the original is a parabola. To graph it, I want it to be in vertex form. That's what we've been doing. And actually, to find the inverse, I need it in vertex form as well. I'm going to split the page in half because I'm going to do all the work with the original here, get the graph, then we'll find the inverse and get the graph, and I'll talk about domain and range when we're done. So to get this into vertex form, I have to take the 5 out, leave room for my 0, and keep the 18 waiting at the end. Half of 4 is 2, 2 squared is 4, 4 minus 4 is my 0. So I get 5x plus 2 squared, that's those three things, grabbing that number, minus 20. The negative 4 comes out of the bracket, so it's touched by the positive 5. And then I have my plus 18 at the end, which I'm going to put together. So now my vertex is negative 2, opposite same. It opens up because of the positive 5, and it's going to be 5 times the pattern. So I start with my square pattern, and I multiply it by 5. There's no way I'm doing the 45. I'll have to even see in this case if I can get the 2 and 20 in. My graph might not be big enough. If you were taught a different way to graph parabolas, don't worry about it. As long as it makes sense to you and it works, I'm okay with that. So I'm going to count by ones on the x's. Usually is what we can do when we're graphing parabolas. For the y's, though, I'm going to count by 5s. So that's going to be 20, 5, 10, 15, 20. That'll be negative 20. So my vertex was negative 2, negative 2. And I was opening up and 5 times the pattern. So 1, 2, 1, 4 became 5 and 20. So I'm going to go over 1, up 5. 5 for my scale is just one space because I'm going to go from negative. Whoops, I did that wrong. Let me get an eraser. My vertex is in the wrong spot. Back to my pen. Glad I caught that before we went too far. Okay, so my vertex is at negative 2, negative 2. Negative 2 is actually going to be about there because that is negative 5. From that point, I'm going to go over 1, which is a full square, up 5. So it's going to be 2, 3, 4, 5. So about the size of a full square. And I do the best I can. Another way is negative 2 up 5 would give me positive 3, which should be approximately there. Now I'm going to go over 2 up 20. So if I go up 20 from negative 2, that should put me at about 18, or the equivalent of 4 spaces up. I'm going to join them up. And I'm going to label it with the original equation. It was plus 20x plus, I'm messing up my signs here. Yep, plus 18. And actually, I think I'm going to do the domain and range while I'm here. So the domain of every parabola is all real numbers, because eventually this parabola, if we could make our graph big enough, would span all the way to the right and all the way to the left. The range of a parabola always depends on where the vertex is. The vertex is at negative 2 in this case, and I want to say, well, the range is all y's that are bigger than negative 2. Mathematicians do not like to write, they're lazy. So instead of saying y bigger than negative 2, they came up with a symbol, the greater than symbol. And it always opens to the bigger thing. So this literally means y is bigger than negative 2, or equal to, because that's where it starts. Now, they also want us to find the equation of the inverse. And I'm just going to get a different color for my pen so that all of our inverse work is green. I need to switch x and y, and I could switch x and y in this original equation, but then I'm going to have a y squared and a y, because I'd have 5y squared plus 20y, and that makes it really, really hard to solve for y, because the steps for the inverse are switch x and y, solve for y. So I'm actually going to work from the vertex form because it is going to be much easier to solve. We won't get a pretty answer, but it'll be easier. So now, first step is to switch x and y. So that's the inverse. But mathematicians said this is poor form. We always write equations as y equals. So now I'm going to start to do some math. I'm going to work in towards that y. I took this subtract 2 over and I added it. Now this 5 is multiplying, so I'm going to divide it. I can't actually do the division by 5, so I'm just going to write it over 5. Divide it by 5. Now I want to deal with this square. In the inverse or opposite operation of square is square root. So I have to make a big square root to catch all of this. And most numbers have two square roots, the positive one and the negative one. So we put a plus minus there. Now I'm going to take this plus 2 over and subtract it. It doesn't matter where you write it. I could go plus minus the square root, subtract 2. But sometimes these are like vacuum cleaners. They literally suck things inside of them that shouldn't be there. And I don't want that negative 2 to get sucked inside of it because it goes over after we square root. So I'm actually going to put the subtract or negative 2 at the front to protect it from getting sucked in. So that's the equation of my inverse because I've been able to isolate the y. I have a lot of graphing experience. I've been teaching for a lot of years. I don't want to graph this. I do not want to make a table of values and try and graph this because it's just an ugly equation. But I don't have to worry about graphing the inverse from an equation because we have the graph of the original. To graph the inverse, it literally just means switch the point. So this point was at negative 2, negative 2. If I flip-flop that, it stays at negative 2, negative 2. This point was at negative 3 and positive 3. So if I flip-flop that, it's going to be positive 3, negative 3. I literally just flip around the points. So positive 3, negative 3 is going to be about there. This point was at negative 1, positive 3. I just look at the location on the graph. So if I invert that, it's going to be 3 and negative 1. And now this becomes squished because of my scale, but there's the inverse. So I didn't actually have to graph that nasty equation. I just picked some points off of this, and I could pick some more, but I'm happy with that. And I'm going to label it. So this is y equals negative 2 plus or minus the square root of x plus 2 over 5. And now my domain and my range. Well, the domain is the x's used. This graph starts here horizontally and goes that way. There's nothing on this side. So it's starting at negative 2, and it's only x's that are bigger than negative 2 or to the right of it. The range, now this would take a long time, but this parabola will keep opening up and up and up and up, and down, 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 or the sideways parabola. So the range is all real numbers. But look, XER becomes YER because inverse literally means to switch x and y. Y greater than or equal to negative 2 becomes x greater than or equal to negative 2. So I could have given my domain and range right from this answer and just switched them. Just make sure to switch your variables as well because domain is still x and always is, range is y. I'll get students who will switch it, but they'll say domain is y greater than or equal to negative 2 and range is XER because they just write those in the different spots. You have to switch the letters as well.